Tellurium, element 52 on the periodic table of elements is our element highlight for today. This is Norris Teaches Science with me, Mr. Norris. This is a physical science edition video. This video would go into the physics section of physical science. It's talking about electricity, and I did a video on electrical charges. This is the next video in the series. If you watch these out of order, I'm sorry, you may be a little lost when I talk about some stuff. If not, if you want to, go check out the other video and then come back to this one. But today we're going to talk about electrical current. So your goal for this video is say I can discuss the components of an electrical current and how they affect the electrical charges. So electrical current is a continuous flow of electrical charge. Remember, electrical charges usually deal with electrons. And usually in electrical current, it's going to flow in one direction. All the current flows in one direction. And there's two types of currents. You can have direct current, which we abbreviate DC, and alternating current, AC. So let's talk about each one. Alternating current is known as AC, right? Alternating current. And this is where the flow of electrons can reverse the direction. It can go one direction and then it can reverse its direction and go the next direction. Now, everything has to stop in reverse direction. It's not like it's one. Some electrons going one way, some's going the other way. They all have to go in the same direction. But most homes and schools are wired in an alternating current. Direct current we abbreviate DC. And this is where charges only flow in one direction, no matter what. And most battery operated devices would be in a direct current. Now, speaking current, again, is the flow of electrons through the wire. When you increase your current in the wire, what you mean is you're increasing that there's more electrons in the flow of the wire. Now, the unit for current is ampere or amps, or we abbreviate it with just the letter A. I'm going to do another video about electrical math, and knowing these units is going to be really important when doing those types of formulas. Resistance. Resistance is the opposition to the flow of charges in a material. Basically, resistance is trying to stop the flow of electrons. So you can see these blue little dots are trying to go through the wire. Sometimes they run into a little spot. Those little spots are resistance. Now, the unit for resistance is ohms, but we use the omega symbol, when we write the unit for resistance. And the last thing is called voltage. Sometimes voltage is called potential difference. Either term works, it means the same thing, but it's the difference in electrical potential energy between two places in an electrical field. You probably have heard of volts before. If you like a 9-volt battery, if you look at most batteries, they have a voltage on there. Now, speaking of that, that means that the unit is volts, and we use a capital V to represent volts. Now, when we talk about current and wirings and stuff, you have electrical conductors and electrical insulators. Conductors is a material in which charges can flow easily. You're looking at your metals here, like some of the better ones are like copper and silver. Mainly copper. Most wiring is some form of copper. Electrical insulators the charges cannot flow easily. They don't really flow. Wood, plastic, you probably heard of, or rubber. People who work with electricity usually wear rubber gloves so they don't get electrocuted. Stuff like that, they don't allow the electricity to transfer within it. And there are a couple of factors that affect the resistance that can factor into current. One, the length of the wire. The longer the wire, the higher you're going to have your resistance. Long wire, high resistance, while short wires, low resistance. The reason why is because the longer the wire, the longer the electrons have to flow, and sometimes they hit the side of the wiring, and that could slow them down. The thickness of the wire is a factor too. Thick wires have low resistance, while narrow wires have a high resistance. Think of it like this. There's 50 people in a room, and there's a small door. It's going to take a long time for those 50 people to get out. Right? That means it has a small diameter. But if we had a bigger door that could allow 3 people out at a time versus 1, then you wouldn't have to wait as long for everyone to get out. That would cause low resistance. And so the thicker the door, the wider the door, more people. The thicker the wire, the more electrons. Temperature. High temperatures equals high resistance because temperature increases the how often electrons will collide with each other more. They get more erratic during that stage, so you want more low temperatures. That's why if you've ever seen the server room of any type of building with all the different computer components, the server room is kept at a colder temperature than most of the building because low temperatures equals low resistance. And then the last thing is the next thing is the composition or the makeup. We just talked about conductors and insulators. Conductors equals low resistance while insulators equal high resistance. If you think back, conductors allow the electrons to flow, so that it wouldn't matter, but insulators don't allow the flow, so it's going to have a high resistance. And the last thing is resistivity, and that is actually how strongly a material opposes the flow of an electrical current. And that relates back to the composition. But just a little bit about electrical current. We're probably going to do the next video on electrical math. So make sure you bring a calculator when you get to that one. And I hope you learned something today. I'm Mr. Norris, and I'll see you at the next video. Bring a calculator.